Hi everyone, this is Vivek Robinson from Ramco Institute of Technology. I'm working as an assistant professor in CSE department. In today's video, we are going to see about different type of CPU scheduling algorithms. So CPU scheduling is a process that allows one process to use the CPU while another process is delayed due to some unavailable resources like IO, or maybe the CPU is replaced by some other process, or the CPU may be in idle state. Okay. So the purpose of CPU scheduling is to make the system more efficient, faster, and fairer. When we go for a CPU scheduling algorithm, we may need to familiarize with some terminologies like arrival time, completion time, burst time, turnaround time, and waiting time. Okay. So the arrival time is nothing but the time at which the process arrives in the ready queue. Completion time is nothing but the time at which process completes its whole execution. So the burst time is nothing but the amount of time required by each process to complete its execution. So turnaround time is the difference between the completion time and arrival time. Waiting time is the time difference between the turnaround time and burst time. Okay. We can divide the CPU scheduling algorithm majorly into two types. One is non-preemptive algorithm. The another one is preemptive algorithm. In non-preemptive algorithm, once the process gets into the CPU, it will not came out of the CPU until it completes its execution in the CPU. But in preemptive scheduling algorithm, the process may preempt uh, based upon certain conditions. Like if we are using some priority scheduling algorithm, if a new process comes into the ready queue with higher priority, then the older process executing in the CPU will get preempted and replaced by the higher priority process. Okay. So this is the major difference between non-preemptive and preemptive scheduling algorithm. Okay. In non-preemptive, there will be no preemption until the process completes the execution in CPU. But in preemptive, the process may get preempted from the CPU. So here I have listed out the different kind of CPU scheduling algorithms. Like as I have mentioned earlier, we are having two categories like preemptive and non-preemptive. So we can further divide the non-preemptive scheduling algorithm into different types like first come first serve, shortest job first, longest job first. Okay. In similar way, we can divide the preemptive into priority scheduling, round robin scheduling, SRTF, shortest remaining job first scheduling. Okay. So these are some kind of different CPU scheduling algorithms. Okay. So in this video, we are majorly focusing on non-preemptive scheduling algorithm. Okay. So we will see three major scheduling algorithms like first come first serve, shortest job first, and priority scheduling. Okay. So the first one we are going to see is first come first serve scheduling algorithm. So before that, I have mentioned the purpose of scheduling algorithm, why we need to do the scheduling. Okay, so the scheduling is important to maximize the CPU utilization and maximize the throughput and minimum turnaround time. Okay, so you also know that the turnaround time is nothing but the amount of time required to complete the particular process. Okay, so we need to choose some scheduling algorithm so that the turnaround time for the particular process should be minimum. Okay, and also minimum waiting time and minimum response time. Okay, so the first scheduling algorithm we are going to see here is the first come first serve algorithm. In the first come first serve algorithm, the process executed in a first come first serve manner. Okay, which means which process comes into the ready queue first will get the CPU first. Okay, so it's a non-preemptive scheduling algorithm and it's easy to implement. So the concept behind the first come first serve algorithm is a FIFO queue, first in first out queue. Okay, here, when new process enter into the ready queue, its PCB is linked to the tail of the queue. We all know that the PCB stands for process control block, and it stores all the information about the particular process, like process ID, burst time, arrival time. Okay, so those informations are stored in the process control block. But this is the easiest approach to schedule the process, but it suffers from convoy effect. Okay, so if the burst time of the first job is highest among all the process. Okay, but also, the performance of the first come first serve algorithm is also poor. Okay. Let's understand the first come first serve algorithm with one example. Okay, here I have listed out one example. Like here I'm having five processes P0, P1, P2, P3, P4, and the arrival time and burst time. Okay. Now we have to calculate the completion time for each process. Okay. So here process P0 arrived at the time of 0 in the ready queue. Okay. So here I'm using first come first serve algorithm, which means the process who comes into the ready queue first will get into the CPU first. Okay. So here process P0 comes into the ready queue at the time of 0. So it directly move to the CPU for So that here the process B0 will come into the CPU for its execution. Okay. So the burst time of process P0 is 2. So the process B0 execute 2 unit of time in CPU. After that, it will remove from the CPU. Okay. So at the time of 1, the process P1 will come into the CPU. At the time of 2, the process P2 will come into the ready queue. Okay. So once the P0 will move from the CPU, there will be two processes waiting in the ready queue called P1 and P2. Okay. So when you see the Gantt chart at the time of 2, P1 completes execution in CPU, and in the ready queue, the process P1 and P2 are waiting to schedule. Okay. So from those two processes, which one we have to choose means the process who come first into the ready queue, we have to choose. Okay. So when we look into the 1 and 2, the process P1 comes in before process P2. Okay. So that we have to choose the process P1 at first, and then we have to choose the process P2. Okay. So that I have choose to process P1 here. The burst time of process P1 is 6. Okay. So at the time of 8, the process P1 completes execution. Okay. So at the time of 8, we also have some process in the ready queue, okay, called P3 and P4. Okay, so those are arrived at time of 3 and time of 6. Okay, once P1 is complete execution at the time of 8, we will be have 3 more processes in the ready queue called P2, P3, P4. So from those 3 processes, you have to choose the next process who came first. Okay, so here process P2 comes in before P3 and P4. So I have chosen process P2 for execution. So the process P2 burst time is 4. So the process P2 has executed for 4 units of time, and at the time of 12, the process P2 completed execution. Okay. Next, I have chosen process P3 because the arrival time of P3 is 3. Okay. So the P3 runs for 9 unit of time. Okay. So at the time of 21, the process P3 completes the execution. So finally, I'm having process P4. So I have scheduled the process P4 at the last. Okay. So the burst time of process P4 is 12. So at the time of 33, the process P4 completes execution. Okay. So here I have write down the completion time of all the process from the Gantt chart. Okay. So the process P2 completes at 2, process 0 completes at 2, process P1 completes at 8, process 2 completes at 12, process 3 completes at 21, process 4 completes at 33. Taking the values from completion time. So here I have calculated the turnaround time. So the turnaround time has been calculated by the help of the time difference between the completion time and arrival time. So here the turnaround time of process P2 is 2 minus 0, 2. Process P1 is 8 minus 1, 7. Like that I have calculated the remaining. So the waiting time has been calculated with the help of the time difference between the turnaround time and the burst time. Okay. For example, here the waiting time of process P2 is 10 minus 4, 6. Okay. So this is how you have to calculate the turnaround time and waiting time. Okay. For calculating the average waiting time, I can add the waiting time of all the process and divide by the number of process. So here I'm having 31 divided by 5. Okay. So the next algorithm we are going to see is shortest job first algorithm. Okay, so in SJF scheduling, the process with the lowest burst time among the list of available processes in the ready queue is going to be scheduled next. Okay, so here, if I am having 5 processes in the ready queue means I have to choose one process which has the lowest burst time. Okay, so it's easy to implement in batch system, but this scheduling algorithm is impossible to implement in interactive system where the required CPU time is not known. Okay, so I have given an example for SJF also. So here I'm having 5 processes P1, P2, P3, P4, and P5, and the arrival time of processes P1, P3, 1, 3, 6, 7, 9, and the burst time is 7, 3, 2, 10, and 8. Okay. Next, we have to calculate the completion time for all those processes. So here at the time of, so when we see the Gantt chart, at the time of 0, I'm having no process arrived in the ready queue. For example, here the first process arrived in the ready queue at the time of 1. Okay. So in the Gantt chart, at the time of 0 to 1, my CPU will become idle. Okay. So because there is no process to be scheduled. Okay. So that I have emptied the box at the time of 0 to 1. Okay. So next at the time of 1, process P1 arrived in the ready queue. Since that's the only one process available in the ready queue, I have directly scheduled those processes in CPU. Okay. So I have put the process in the CPU. the burst time for the CPU is 7. Okay, so the process P1 execute in the CPU for 7 units. Okay, so at the time of 8, process P1 completed execution. Okay, so at the time of 8, when we look into the ready queue, I will be having 3 more processes, P2, P3, P4. Okay, so among those 3 processes, which one I have to choose? In FCFS, which one comes first? I will choose that one. Okay, but in SJF algorithm, I have to choose the process from the ready queue, which one has the lowest burst time. Here I'm having 3 processes, P2, P3, P4. Okay, so among these 3, I have to choose the one which has lowest burst time. Here, the process P3 only has the lowest burst time. Okay, so I have choose the process P3 and put into the CPU. P3 executes for 2 units at the time of 10. P3 completes its execution. Okay, and also at the time of 10, I have one more process arrived in the ready queue called process P5. Okay, now I am having 3 processes, P2, P4, P5 in the ready queue. Okay, so among these 3 processes, which one I have to choose? I have to choose the process P2, since process P2 has the lowest burst time. Okay, so I have scheduled process P2 next. So the process P2 execute for 3 units at the time of 13. The process P2 completed execution. So after that, I have chosen P5 instead of P4. Why means the P5 has the lowest burst time. Okay, so I have chosen P5. So the P5 executes for 8 units at the time of 21. The P5 completes its execution. Okay, so finally I'm having only one process in the ready queue called P4. So I have put that process into CPU. So the process P4 execute for 10 units at the time of 31. The process P1 completed execution. Okay, so here I have listed out the completion time from the Gantt chart. So the process P1 completed 8, process P3 completed 10, process P5 completed 21. Okay, so next I have calculated the turnaround time. So the turnaround time has been calculated by the time difference between completion time and arrival time. Next I have calculated the waiting time. So it's nothing but the time difference between the turnaround time and burst time. Okay, so this is how the SJF scheduling works. Okay, so the next one we are going to see is the non-preemptive priority scheduling. Okay, so as of now we have seen 2 scheduling algorithms, like, right? So FCFS and SJF. In both the scheduling algorithms, the input given from the user side is only process, arrival time, and burst time. But in non-preemptive scheduling, in non-preemptive priority scheduling algorithm, we'll be having, we have to consider one more parameter called priority. Okay, so here each process will have its own priority along with the arrival time and burst time. Here the processes are scheduled based on their priorities. Okay, so here the lower the number or higher the priority. For example, the process P1 has priority 1, the process P2 has priority 7, means the process P1 has the highest priority than process P2. Okay, so I have given an example for this algorithm also. So when we look into this table, I have one more column called priority. Okay, so each process will have its own priority. For example, here P1 has the priority of 2, P3 has the priority of 3, P4 has the priority of 5. Okay, so among these processes, which one has the highest priority? Means the process P1 has the highest priority because the process P1 has the lowest number, and the process P7 has the lowest priority because the highest value here is 10. Okay. Next, I have given the arrival time for each process. Here the process P1 arrived at the time of 0, process P3 arrived at the time of 1. Okay, so like that. And also I have given the burst time. Okay, so these are the input only given in the question. Okay, so remaining thing we have to calculate. Here I have calculated the completion time, turnaround time, waiting time, and I have calculated the one more column called response time. Okay, so the response time is nothing but the amount of time from when a request was submitted until the first response is produced. Okay, so I will show how to calculate the response time. Okay, so first we have to calculate the completion time. Then only we can calculate the turnaround time, waiting time, and response time. Okay, so here how we schedule the process. Okay, so the process will scheduled based on their priority. Okay, but they are chosen based on the arrival time too. Okay, so here the process P1 comes at the ready queue at the time of 0. Okay, so at that time there will be no process available in the ready queue, so I have directly moved that particular process P1 into CPU. Okay, so since I'm using non-preemptive scheduling algorithm, once the process gets into the CPU, it will not preempt it until it completed execution. Okay, So here the burst time of process P1 is 3. So at the time of 3, process P3 completed execution and came out from the CPU. Okay. So at the time of 3, I will be having two more process waiting in the ready queue called process P2 and P3. Okay. So from those two processes, which one I have to choose mean which process have the highest priority I have to choose. Here, the process P3 is having highest priority than the process P2. Okay. So I have chosen the process P3 next. Okay. So the burst time for process P3 is 4. So the process P3 execute for 4 unit of time. At the time of 7, the process P3 completed execution. Okay. Once process P3 completed execution, okay, so at the time of 7, I will be having 5 more process waiting in the ready queue called P2, P4, P5, P6, P7. Okay. So at the time of 7, I'll be having all the process waiting in the ready queue. Okay. So among all the 5 process, which one I have to choose means I have to choose the process P6 because among P2, P4, P5, P6, P7, P6 has the highest priority than all other process. Okay. So that I have choose the process P6 next. Okay. So the burst time for process P6 is 4. So the process P6 execute for 4 unit of time. At the time of 11, the process P6 completed execution. Okay. So next from P2, P4, P5, P7, I have to choose which one means I have to choose P2 because the P2 has the, sorry. So among P2, P4, P5, P7, which one I have to choose mean I have to choose the process P4 since the process P4 has the highest priority among all others. Okay. So the burst time for process P2 is 2. So the process P2 execute for 2 unit of time. So at the time of 13, process P4 completed execution. Okay. So next process P2 has the highest priority. So I have taken process P2 from the ready queue. So the burst time for process P2 is 5. The process P2 execute for 5 unit of time. Okay. So at the time of 18, process P2 completed execution. Next, I have chosen process P5. So process P5 executes for 9 unit. Next, I have chosen P7. P7 execute for the 10 unit. Okay. So at the time of 31, sorry, at the time of 37, all my process completed. Okay. So here the completion time has been write down from the Gantt chart. Next, we can calculate the turnaround by subtracting the arrival time from completion time. Next, the waiting time by turnaround time minus burst time. Okay. So how can we calculate the response time? Okay. So the easy way to calculate the response time is, for example, the process P1. What is the response time for process P1? Okay. So here I'm having process P1. Okay. So as I have started earlier, so the response time is the amount of time from when a request was submitted. Okay, so when a request was submitted for process P1, so here the process P1 request was submitted at the time of 0. Okay, so the response time of process P1 is 0. For example, if we take the process P4, when the response was submitted for process P4, the response was submitted at the time of 11. Okay, so the response time of process P4 is 11. Okay, similarly for process P6, so the response was submitted at the time of 7. So the response time for process 6 is 7. Okay, so this is how to calculate the response time for each process. Okay, next we can calculate the average waiting time by adding the all process waiting time and dividing the total number of processes. Okay, so I hope you guys familiar with non-preemptive scheduling algorithm. Okay, so we will meet in the next video. Okay, bye.